into working at Trilio. I started as a senior solution architect. I then progressed into leading the team of solution architects. So it's all in the pre-sales world. Were quite naturally doing presentations and demonstrations. And then after a while, gravitated into the world of product management, where I able to take my expertise and allow to look at the strategy around Trilio and how it fits into the marketplace. Trilio has been around for over 10 years. We've got a fantastic relationship. In fact, we're a tier 1 ISV with Red Hat. We are integrated throughout Red Hat's portfolio. I'll take you through a few slides later on as to show you how that really fits and how that applies to you. It's easy for me to sit here in a Trilio shirt telling you how wonderful our relationship with Red Hat is, but for you as listeners, you want to know how that really applies to you and the whole Red Hat portfolio, and I'll take you through that in a few slides. But ultimately, what Trilio provides backup, recovery, disaster recovery software for OpenShift, Red Hat OpenStack platform, and the up-and-coming Red Hat OpenStack services on OpenShift. So yes, I'm going to take you through this wonderful world of backup and restore and disaster recovery. I'm going to make it as exciting as possible. It's certainly going to be exciting for me. Like any live demonstrations, the last thing you want to see is some like little alerts popping up on the corner of my eye to do with infrastructure issues. So if it's not exciting for you watching this, it's certainly going to be exciting for me, and my heart is going to be racing. The fact that those Ceph errors I'm seeing, I can hopefully just ignore as we go through today's session. So fingers crossed that I've done the right sacrifices to the demonstration gods today. So without further ado, this session is about doing live demonstrations, but I will take you through about 5 or 6 slides just to get you to understand where we fit into the world of OpenShift and how that will apply to you as you move forward and you progress and build out your OpenShift environment, certainly in the world of OpenShift virtualization. So I'll take you through a few slides. So what is Trilio and how does it apply for OpenShift? So we are a certified operator that you'll find very easily on the OpenShift Operator Hub. So if you are easily distracted and you've got another session up, people are watching this on their desktops or their laptops and they're already doing their work, do a search for Trilio in Operator Hub, you will find us in there. And we just actually launched or released a new version, literally just today, version 404. But the version 4 branch really concentrates on being knee-deep into the world of OpenShift, where we have integration into the OpenShift console. Of course, I will show you that deep integration. We provide advanced cluster management policies, so you can find us, publicly available on the right GitHub repo, so you can apply those policies to install Trilio, to set up Trilio, to make backups automatically of your environment of Trilio, of course. And we've also got certified Kubernetes Ansible roles as well. So that's all part of the 4 release. So what is Trilio? So once you have it installed, we're an operator. So of course, we're extending functionality into your OpenShift deployments. And that functionality allows you as a user, an administrator, to back up your deployments that are based on containers. You might have virtual machines. So you might have moved over into OpenShift Virtualization. You might be considering moving from VMware into virtualization. We'll protect all that. We'll protect Helm releases. We'll protect operators. In fact, our ability to protect those operators is driving a lot of traction. So if you've got operators that you want to back up, have a need for or concerns about not being able to maybe roll back versions of operators, so you've upgraded and it's very hard to roll back down to previous versions, Trilio can provide that features and functionality for you. We have a lot of people who run things like pipelines in their environment, lots of them, and we're able to package them up and back them up and recover them as appropriate across many clusters, you know, and certainly at scale. So we protect the containers, protect the persistent volumes of the disks of the virtual machines, and those presented back up into containers, and we can store that on any storage which is provided through S3 or through NFS, or if you're out on the internet on something like Azure, you know, blob or container type storage that's out there as well. This is all storage agnostic as well. So that means that if you have a requirement to do things like regional DR or anything like that, where we've got GA products for the last couple of years, which able to be able to do your disaster recovery on anywhere. So you can back up your workloads on your existing clusters and recover them to any cluster, and that's based on any storage. So there's no dependencies on specific storage to be able to enable those features. We can provide those features to you today, which has been GA for the last few years for us, and we're able to do that recovery between many different clusters, wherever they're situated, close by, in close proximity, or you know, across the world. And so you can recover these to any clusters. You can also bring on workloads into OpenShift as well. So if you've got workloads that are running on a, you know, heaven forbid, you know, some other type of Kubernetes platform, you can bring them in and have them running on your OpenShift as well. So if you think about your development cycle and where your developers sit and how they're working with OpenShift today or Kubernetes, think about how you can streamline that. Trilio can help you streamline that and bring you all into a world of OpenShift. The capabilities of Trilio basically stems around the way we do our backup format. So obviously the features and functionality of having Trilio installed in your cluster means that you're able to back up your workloads, backup and recovery to your existing cluster. So that might be a personal cluster, could be a production cluster. But if there's a requirement to have you recover workloads, recover all of the deployments, the Helm releases, the virtual machines, you want to be able to recover them back to the original cluster, then we provide that obviously as a service to your particular users. We don't really differentiate between containers and virtualization. Of course, we treat virtualization as something special. Virtualization users tend to want slightly less complexity from the world of containers. So we have a lot of focus on being able to make that easy for users to use and back up and recover virtual machines easily on your OpenShift clusters. But of course, we don't stop there. Everything that we back up, where we store it, so this cloud here represents a backup storage. Everything that we put on there allows you to then recover to any other cluster. That format is self-contained. There's no backup catalog that you need to back up. There's no external service that is maintained by a backup team where you have to back up a backup catalog. Everything that we encode, which is open source, the format that we use is open source. You know, we write out YAML and JSON, encrypted, of course, where you want to encrypt your workloads. And the format of the storage is open source QCOW2. Now, why do I call out that? Because, well, if you think about it, we've got storage agnostic capabilities over here. So this could be ODF, it could be something else. We back up to this QCOW2 format. It's the metadata that we capture which describes what that would look like when it comes to a recovery. So for you as a user, it allows you to recover those that data to any cluster as and when is needed. And this could be the same architecture, just in different data centers. This could be disaster recovery scenario. But we can go a little bit further as well. If you have a difference in your architecture or in your infrastructure, For example, this might be on-prem OpenShift over here running ODF. And then you might be using some native storage over on Amazon or Azure. So you might be using EBS type volumes over on Amazon, for example. Well, we can do backups from your ODF and then do recovery to EBS over here, just as an example. But any of that metadata can change. If you have restrictions over here, that need to be changed over here. If you've got metadata over here, that needs to be changed. We have this feature called transformations. They're basically just encoding data. So if you think about the world of OpenShift, whilst we've got lovely user interfaces and you can click through and follow wizards, think about the back end. I always think this in the world of YAML. I'm a techie, so think of the world of YAML and just think of those transforms. They're just extra lines in your YAML that says, okay, instead of this, do this instead. And it really is that simple to describe those differences in the architecture. So I promised before, I said, where do we fit into the Red Hat ecosystem? Well, you can clearly see that we fit right central. It's easy for me to put a diagram where we put ourselves central, but this makes sense. So in the ecosystem that I'm certainly going to be taking you through today, my live demonstration environment today really is made up of Ansible. It's made up of advanced cluster management. It's made up of OpenShift clusters. And of course, we've got Trilio, which is deployed across your multiple OpenShift environments. So even though this is a separate box, it's actually deployed, of course, as an operator into your OpenShift environment. But this whole ecosystem with this particular type of topology works really, really well with each other, where we have Ansible, which is able to talk to advanced cluster management, of course. We've got Ansible, which, of course, can interact with the features of Trilio. And you interact with the features of Trilio really through OpenShift. I should point out that don't treat Trilio as anything strange that is getting installed into your OpenShift environment. You would interact with us just through normal custom resource definitions. So, for example, and the reason why I call that out is it allows you to just continue using your existing OpenShift just as normal. We just now provide you with new custom resource definitions. So this allows you to have a custom resource of like a backup, and you've defined what that backup is. You can have a custom resource of a target. So one of our custom resources is a target, for example, which tells you where we're going to store the backups. Then you just define what that target is. So that means that you can continue to use things like your standard OC command line client, or if you like to use the universal kubectl, whichever you prefer. If you've got other tools that interact with your OpenShift environment, you just continue to use them. Trilio should definitely not get in the way of what you're trying to achieve. And I really want to make that really clear. We've designed Trilio to make sure that we're not getting in the way. We want to just be as seamless as possible. We don't have an external tool, don't have to think of anything else apart from, hey, I've now got Trilio installed. I can just wrap my data, my applications around extra YAML or an extra click on the user interface to be able to protect and recover these things. But we can extend this a little bit further as well. So if we just expand this a little bit further in terms of like the wider ecosystem, just so I can just have an excuse to talk around some other things. Of course, to the side, we're talking some OpenShift virtualization today, but obviously at the side, we also have the likes of OpenStack as well. Well, with Trilio, we can also be able to facilitate migrations from legacy type systems of like VMware, bring them into an OpenStack cloud, or for example, if you're considering moving into OpenShift virtualization, obviously there's an MTV operator that you can have. That's part of Red Hat's catalog. And so using Red Hat's MTV service, you're able to import your workloads onto OpenShift. And of course, where do we fit into both of those scenarios? Well, Trilio has a native tool for OpenStack for protecting those workloads as well as migration. But of course, we're talking OpenShift today. Of course, once you've brought your workloads over into the world of OpenShift, which is very easy to do, we're able to then, of course, continue protecting those those migrated virtual machines. And as I say, this is just an extension of what you probably already know. And of course, you can automate every single step of the way through this particular journey, of course. So I'm going to bring you on to one of the last things I want to talk about before we jump into the demonstrations. As I say, today's session is about doing some demonstrations. But I want to touch on one very important feature of Trilio. Trilio provides the ability for you to do backup of your workload from one cluster and recover them to any cluster. So you've got your OpenShift cluster, you might have 5 OpenShift clusters. You might be managing through ACM and or through the world of Ansible. And you have a requirement to back up all those deployments, virtual machines, persistent volumes. So you can do that all day long using Trilio. You probably have a focus of, okay, if any of those clusters go down or any of my data centers goes down, then I have a requirement to fail over to another cluster or another data center. So we recognize that. I've already told you that we can, when we do a backup over here, I've not clicked through this yet. So when we do a backup and we do a write to a backup to some storage, I told you before, we can recover to any cluster based on the backups. We don't need any catalog. You can just read the backups directly and we can recover to any cluster. But we recognize the fact that when you do a disaster recovery, time is of the essence, mainly. So what we've done with Trilio Continuous Restore, we have the ability to actually improve the recovery time objective when it comes to disaster recovery. Very, very important in today's world where people have no patience whatsoever. So what is Trilio Continuous Restore? Let me build this out. So Trilio Continuous Restore is essentially a feature where you can have multiple clusters watching for changes of backups as they occur. And what this means is we can have a cluster, say a source cluster, so this could be your primary cluster, performing a backup as normal. But because we've got Trilio Continuous Restore enabled on this particular backup target, when we enable Continuous Restore on a backup target, it's known as an event target. And what happens there is we've actually got services that are running on your secondary cloud, so your other clusters now in your other data center. They are watching for changes of that data. So we're doing backups from your primary data center. It's watching to see, are there any changes that have occurred onto that same backup target? And if any changes have occurred, we actually, in the background, basically pre-stage the data on your target cluster. Now, why do we do that? Well, if you think about it in terms of a disaster recovery scenario, whilst we can always do a recovery to any cluster, the recovery will involve taking data from your backup storage and then creating them as persistent volumes on your new cluster, your recovered cluster. Arguably, the longest time of the recovery will be the time it takes for data to traverse and read from your backup storage, which sometimes, not all the time, but maybe it's appropriate that the backup storage is not the fastest. It's designed for scale. It's designed for resilience. And so therefore, this is slower storage than your primary storage. So we have to read the data and then populate your primary storage. So that takes time. So in terms of RTO, that is usually the longest tail, the longest part of the recovery time. What Continuous Restore has already done is the fact that it's preempted the fact that at some point you're going to recover this data. And so what we do is we every time there's a change, we're able to populate a target cluster. And we populate that target cluster basically with snapshots. So we've got a backup over here. We've got a backup that's now on your backup storage, but we've also taken that backup and we've created a snapshot on your primary storage over here. So when it comes to an event, such as a disaster event, the data center has gone down. What happens is, instead of us having to retrieve the data from that slower storage over that potentially slower network, to recover your data, it's already there as a snapshot. So of course, what's going to happen is we're going to do a snapshot-based restore, so which is going to be very quick. And of course, the last stage, of course, is just recovering the actual pods, the virtual machines, the metadata associated with that. So again, the instantaneous restore is what sets apart the continuous restore, and really, really useful in a disaster recovery scenario. One last slide is, I'll go through this quickly because, as I say, this session is about demonstrations. Got about 30 minutes, 25 minutes of demonstrations, mostly watching backups occur. So I bet you're riveted to watch that. And again, it's very exciting because, as I say, an alert just popped up in the corner of my eye. So it's going to be exciting for me at the very least, but it's still backup and recovery in a very exciting way. But very quickly, before I get there, I just want to just go through a scenario where this is actually used in a more real world scenario. This, what I'm going to show you here, it's based on containers, but it's irrelevant. It applies to containers and virtual machines in equal capacity. This was a live demonstration we actually did at the Red Hat Summit quite recently, where basically we had event-driven Ansible involved as part of this process. Basically, this was a hands-off process. The idea here is the fact that ACN does what it's meant to do. It's making sure that Trilio is installed, it's configured correctly, all the targets are set up, everything's in place for protecting my cluster. An application was deployed. This was an important application for this. I'll go through this quickly. It's not highly relevant, but this could be any number of applications that you would have in your particular cluster. We've got Dynatrace monitoring this environment, and this is where where everything all comes into playing in a complete hands-off scenario. We did a backup. Continuous restore was enabled. So of course we've got a deployed application. This deployed application, the data was already then resided in your data center number 2, your failover data center. It's all ready for an event. Because we had Dynatrace monitoring the environment, an event occurred. Dynatrace basically said, hey, look, that data center has gone down. EDA automatically was watching for the alert. And at this point, everything was all hands off. We didn't touch anything. All this happened here was an event happened in the data center, but because we had Trilio installed, we had Trilio continuous restore enabled, it was completely hands off. Everything happened in an automated failover fashion using Dynatrace, event-driven Ansible, Trilio doing the recovery, and then finally, in this case, we kicked off Argo CD to redeploy the application, the stateless part of this particular demonstration. But that was all hands off. The only thing that we needed to do here was cause an event. In this case, data center failed. But because we had everything in place, all these lovely tools of ACN, Ansible automation platform, Trilio with continuous restore, and your favorite monitoring service, it was completely hands off in terms of a failover. That was really, really smart. So on to the main event. What I'm going to do now is I'm just going to stop this screen, move some slides around, move some screens around, and then I'm going to reshare my desktop. I'm going to get into the good stuff now. So if I just stop this, share this, and then share my entire screen, go very quickly. Move this over here. We don't need to see this. Right. So I'm just looking on my other monitor. Yes, we're all good. So I have an environment here where I've got a window on the left over here, and I've got a window on the right. I apologize. I've got a wide screen here. I'll try and bring things a little bit closer if you are struggling to look at this on a laptop. You may even have this on a mobile phone, in which case you're very brave. But I'll do my best to show you what's going on here. I'm going to take you through a few example demonstrations. The first thing I'll show you, of course, is how do I get Trilio installed? So the first thing I'll show you the basics. So on the right-hand side here, I've got an OpenShift cluster over here. I've already got Trilio installed. I can take you through the steps, though. Just go to your favorite operator hub, type in the word Trilio, and then follow the installation instructions. As I say, this literally came out this morning, or certainly populated in Operator Hub in the early hours. And so today you'll have 4.04, which is some minor bug fix releases of our 4.0 release. 4.0 release is absolutely brilliant. I say it brings to life our continuous restore feature and this lovely ecosystem that I'm going to show you. So go through the installation process. I'm not going to do the installation. I've already got this installed. Down here, you'll see we've got an extra special thing here, which says enable the console plugin. Tick that box. And what will happen is, I've already got this installed. Over here, we will have Trilio enabled as part of your experience as part of OpenShift. So if you prefer to stay within the realms of OpenShift to manage your workloads, to manage your virtual machines, to manage your everything through the OpenShift console, well, you can also manage your backups, your restores, everything to do with Trilio. You can stay within the four walls of your OpenShift environment. So make sure you take that box and you get this enabled as part of that particular experience over here. Now, that's one particular cluster. I'm just going to change over to this. Now, you've changed it white. I've deliberately gone for like a light scheme and a dark scheme just so we can see the differences. I'm going to be doing a failover from one cluster to another. And that failover, one of the demonstrations is going to be virtual machines from this particular cluster over here into, not Rodolfo's, these virtual machines, and I'm going to fail them over to another cluster over here. So I wanted to just make sure there is a separation. So when I'm going through this demonstration, I've got a few windows. I appreciate I've got windows all over the place, but I want to show you what's going to happen in real time as we do things. So that's why I've done the windows in this particular way. So I'm just going to hide that for the time being. I'm not going to show you a disaster recovery just yet. I'm just going to go through some of the basics. So on the left-hand side here, you might be familiar with advanced cluster management. So advanced cluster management allows administrators to govern what occurs on your OpenShift clusters. It allows you to have central policies in place. It allows you to set various configurations. So you can ensure that when clusters are put into production, that they have the required set of configuration. They have the required software installed, the required security parameters set, etc. So, of course, you can install Trilio as part of that particular process. We provide a policy which will give you and take you through the process of installing. Let me just move this out of the way. Of installing Trilio, sets up the right subscription, make sure that everything's installed and applies the license that you would get from us across your estate. Now, this is disabled. For those that are astute, you're going, hey, Kev, I'm not going to even show you an installation of Trilio. That is absolutely correct. I'm actually using a preview release as part of this demonstration today, only because, as I say, the new version came out only last night or this morning. And so I've got the release, which is just slightly one minor bug before what you would get available today. So I've got this disabled, but ultimately, if you went to the place where you find all the policies, and there's a link in the presentation afterwards where you'll find these policies, you can go through a process of installing Trilio across all your clusters today using this. So that's a great thing of using ACM, of course. But we don't just stop there. We have the ability to do a number of things with ACM. So once Trilio is installed, you want to be able to set things up. You want to be able to make sure that various parts of the configuration is set so your users can just come along and go, hey, I just want to press the backup button. So if I go, for example, in a screen where I create a backup of this particular namespace, and I go and choose a target, and a user might go, hey, I don't know what target to use. I don't know where to store my backups. Well, with ACM, you can have things set up, and this one's an event target, it's irrelevant. You can have things set up so that these things are already set in place for your particular users. So again, just recap on that one. You can install Trilio across the board very easily using advanced cluster management. You can then use policies that will then set up those like targets. Targets are something which Trilio uses to say, I'm going to be storing my backups there. You can set things up like backup plans, which basically says these are the policies, these are the schedule policies, the retention policies that a user should use when they're performing a particular backup. So you can set all these things up. So I'm going to show you like a little demonstration of this. In fact, hopefully, if I show the results page, this might actually happen quite quickly. So let me just go back to this. I don't need to show this, but I'm going to go into this particular screen over here. So again, I've just switched a cluster. This black screen here is this cluster over here, OCP DC4. So again, for the Kenai people, this is a genuine cluster that's being governed by the by ACM. And all I'm going to do is, if I just go and click on targets, this particular policy over here, because I want to show everybody on the call what continuous restore is. Continuous restore, as I say, one of the fundamental things is it uses what we call an event target. So it's like a target, but with an extra flag enabled. And basically make sure that your clusters have that same target available across all your clusters. And because I've got ACM installed, I'm going to delete this on this particular cluster. Now, the timing of everything, the funny thing about this is it's so quick, and there's a refresh, there's a polling interval of about 15 seconds for things to catch up with each other. And what will happen is, in reality, look, that's disappeared. ACM, maybe if I can force a refresh of Advanced Cluster Management. Oh, there you go. It's already realized the fact that, hey, you should have had a target, and it's already gone and recreated that target for us, even before I've had a chance to reload this. So here we go. There's a few seconds ago, it just recreated that target. Now, I appreciate that's a very basic demonstration, but I think it's important to see these basics because I don't want anybody to walk away thinking advanced cluster management is complex. I think once you understand how the policies are written, and in fact, I'll just show you very quickly how these things are written, just so you can walk away. If you're not familiar, there's going to be people on this call who are not familiar. Now, this obviously looks quite complex, but very familiar for people who follow YAML. But ultimately, you have things in here which basically says, I must have this object, and this object is basically just a template of what you would expect to see as the YAML of that particular resource. So if this was a pod, you would have the pod structure of a YAML, a deployment. You might be familiar with these things. Well, this construct here, when I go down to this spec section, is the documented spec of how to create a target with Trilio. So with that concept in mind, you can just have this thing of like, I must have this object installed, and there's some templatizing that goes on here, and that's all we've done. So once this is enabled across all your clusters, basically you enable those clusters by having labels set on your clusters, and basically says, hey, this label is on this cluster, so therefore this policy will apply to that cluster. And in this case, it says, oh, there's no event target, so I'm going to create this event target. And that's all it does. Very, very powerful, very simple, and very powerful at the same time. Usually I'll go along and delete a backup as well as part of these demonstrations. I appreciate, we're getting through the time quite quickly. So I'm not going to go through and do that. So I usually come along, delete a backup, and it recreates the backup for you. And what happens there is it basically executes this particular policy. This particular policy says, hey, cluster, you should have backed up this namespace, but you've deleted the backup from this namespace. So I'm going to recreate that backup for you. It was mandatory that you would have at least one backup for that particular deployment. And that's what this policy does. I'm not going to show you that because I want to show you some better things, of course. So that's the world of ACM. And that's I'm going to move away from ACM now, and I'm going to dive into the world of Ansible. Or let me log in. Now, before I jump into the lovely world of Ansible, I just want to take you through another feature I should have pointed out. So, of course, we've got this lovely console integration with Trilio. So I've installed Trilio. I've got this integration with the OpenShift Console over here. I can do my backups. I can do my restores. I can just go through and follow the wizards quite simply. But this feature here is deliberately, I wouldn't say simplified. It's designed for the most used use case in terms of I want to back up a namespace. But of course, we don't just do namespace backups. We have a full-featured user interface as well. So as part of the deployment, we also have our own user interface as well, multi-cluster aware. So it allows us to manage multiple clusters from this single pane of glass. So I can see like an added view. If I wanted to manage things on a second cluster, I can click on this second cluster and I can operate it as if I'm logged in to that second cluster over here. I can do things like, let's just jump onto the primary cluster because it's irrelevant because what I'm going to show you in Ansible. I can do things like I can back up namespaces, but I can also back up applications. I can identify various things by labels. I can back up operators, for example, go through the process of backing up, say, MTV, if that was a requirement. I can back up objects, obviously the minutiae detail. So that's the kind of a level of granularity you can go to. You can back up individual objects in this particular cluster. I should also point out, it's very important as well, I've actually logged in as Kubeadmin. You'll appreciate I've got lots of access to things. It's very important to understand as well. I'm sorry, it's got to 37 minutes into this, that if you logged in as a normal user, role-based access control applies. So if you are a normal user and don't have access to the thousands of objects and the hundreds of namespaces, you've only got access to your 5 namespaces, then that's all Trilio will show you. It's based on your authentication. It's not based on some superpower. But just for everybody's observation, I've logged in as admin across the board, just to show you everything here. And in terms of virtual machines, we list all the virtual machines where you can say, okay, I want to back up in Rodolfo's backup virtual machine over here, and I can follow this wizard process of creating a particular backup. Right. One thing I'm just going to quickly do, though, is very quickly. So I've still got time. So I might do things in a little parallel. I want to show you a couple of things we can do in the world of Ansible. And then I'm going to quickly move into the world of continuous restore for virtual machines. So if you allow me the next 5 minutes, I'm going to take 5 minutes for this next section, and then I'm going to jump into the virtual machine backup and recovery using continuous restore. And I think that'll take me through to the next 10, 15 minutes of things. And if we've got time, I'll show you operator backups as well across multiple namespaces as well. So very quickly, just going to deploy a brand new application. So what I'm going to do here, by the way, is I don't want to confuse anyone. I'm going to just deploy an application to this second cluster. So that's what I'm going to do now. So I'm just going to hide that screen again, just put that over there. And I'm moving back into the world of Ansible. So one of the nice things about Ansible Automation Platform, I love Ansible Automation Platform. This is using Trilio's certified Kubernetes role. And I'm using Ansible Automation Platform with the great feature which allows me to specify various clusters to authenticate into, for example. I can use surveys. Surveys are brilliant. It's basically like a prompted way of specifying those parameters that you would use in Ansible. So those key value pairs. But I think it's just really nice to be able to do things in this kind of like user interface kind of way. So I'm going to deploy an application. It's a simple application and it takes about 1 minute to deploy. That's why I'm doing this. So I'm just going to deploy this application to this particular namespace over here. Now, for everybody who wants to look at virtual machines, this could have been deploying virtual machines, of course. I could have ended up in exactly the same place. But in this case, just for expediency, I'm just deploying a very lightweight application. It'll deploy a front end. It'll deploy, as you can see here, if you can read the screen, there's a MySQL service with a persistent volume. It's going to be on here as well. And it's very quickly just going to deploy this application in here. Now, of course, that's nothing to do with Trilio. In fact, that playbook actually is being run using our certified role. But it's only because there's a nice little convenient feature in there. But that's not the main function, of course. What I wanted to show you, though, is the fact that how we do backup and recovery of those particular applications, of course. So again, using the power of Ansible Automation Platform and the power of Trilio, for example, I can come along and say, okay, I want to back up that application now, and I want to do a well, it's just deployed, so I can do full or incremental. We will work out whether or not a full exists, so we can do the delta. I've literally only deployed that application, so regardless, it would have ended up with a full backup at that point. And I can do a backup at that point. I can click next, and it will execute the Ansible to do a backup of that. Instead, obviously, I want to show you things a little bit more exciting. I told you I want to show you the exciting world of backup and recovery. So doing one backup is okay, but if I can't spell, if I do two at the same time, let's do a full backup, and I click next. I'm backing up to namespace. I could have 3 namespaces, 5 namespaces, 20 namespaces. I could have put them all in there, and they would have been executed through Trilio. So again, this is available out of the box. This is the certified Kubernetes role. You can add this to the world of Ansible automation platform, and then you can come along, and if you prefer not to use things like this interface or this interface or the command line, and you have maybe it's an interface into Ansible, maybe you do everything through an Ansible automation platform, then certainly this is a really, really useful way of being able to do things which are, perception is quite complex of doing a backup of these environments. And of course, we can do the equivalent of restore using this process as well. But this gives you choice. You can do your backups now in a completely orchestrated way. And like I said before, if you prefer to use, I told you I wasn't going to go back to ACM, but if you could have even triggered backups using advanced cluster management as well. But I feel like Ansible is a really good way of doing the ad hoc stuff or responding to an event type of process. So that's going to just kick off in the background now. So that's just going to do a backup. I think that takes about 3 or 4 minutes to do a backup of those two applications. I've got 2 different namespaces, 2 applications deployed. It's just going to churn away in the background. So I'm looking at the time, and I want to get on to more fun stuff. So I'm going to go back into this world. So I said before, we started off in the world of virtual machines. So I have my cluster on the right-hand side. So this is the white environment. This is my source cluster. I've got 2 virtual machines that are running here. Nothing really exciting, I must admit, but there's 2 virtual machines that are very important to me. I'm going to make a backup of those virtual machines. So I'm kicking off, again, that same set of the same playbook, the same tasks. It's going to go through and do a backup of these virtual machines. Now, the architecture is what I showed you on the presentation I showed you before, where there was a source cluster and there was a destination cluster. And in between, there was an event target. There was a storage where the backups are being stored between the 2. So between this particular cluster and this particular cluster, let me just move to the world of here. There is the same event target that is set up. And what is currently occurring is the fact that I'm doing a backup. Sorry, I'm just going to go back to the screen. I'm doing a backup of this. So if I go to this particular screen here, we can see the activity has occurred. I'm doing a backup which was launched through Ansible. I can also monitor that, by the way, by going into monitoring on my advanced cluster management screen, the one provided by Trilio, and I can follow the backup process over here. And I'm going to explain what happens during a backup process, because I think it's important to see what we actually do behind the scenes. So first of all, we go through a process of grabbing all the metadata. We need to understand, based on the input that you've given us. In this case, I'm selecting 2 virtual machines. We need to understand what and how those virtual machines are made up. You know, all the extra metadata associated with them, the networking, the name of them, the PVCs associated with them. And then we go through a process of going through of snapshotting the disk, so the persistent volumes. In this case, we are using ODF, by the way, block-based ODF. We could use file-based. We can use pure storage. We can use NetApp. We can use whatever. Completely storage agnostic. This process remains the same throughout. And we're making a snapshot of those disks now and all the data. And you can see here, it's very quick. When we do quiescent of the disks as well. So for application consistency or data consistency, we are going through that particular process. And then the final stage, of course, is we're going to be uploading these disks to that central storage. So again, back of your mind what this architecture looks like. This is the source cluster. So this is the white environment. This is the source cluster. I'm performing a backup on there, but the backup is special because it's being written to an event target. And as I say, the special part of that is the event target is shared between both of these clusters. And so what's going to happen is once this final part of the backup has occurred, what's going to happen is the continuous restore process will kick in at that point. So we'll just give this another few seconds. Once this is complete, I'll switch over to the continuous restore monitoring page, and we'll see continuous restore kick into life. And what's happening at that point? Well, I'll leave that for when we get there, to save repeating myself. So we'll just give this a moment to finish off the final bit. So this is just uploading the YAML to the backup storage, which again, as I said, is shared between the two clusters. So we finished that backup now. Because the task is to be written to poll, and you're in control of that polling figure as well. Once that's done, that will be marked as complete. We'll have green across the board. Obviously, with Ansible, we don't want to see red. Gold is okay, but red is bad. But green is good. So that's going to finish off momentarily now. So I'm going to close this, and I'm going to show you the power of the continuous restore. Certainly, the magic behind the scene of continuous restore. So continuous restore. So we've got a special tab in our own user interface here. I'll explain how the continuous restore is laid out. Outbound is the source cluster. So outbound is this original cluster where I've got my backups. So down here is I've configured my systems so that when this cluster, which we call OCP dev, has written to this particular this backup, and it's right into this event target, it knows to then notify DC2, this second cluster. It knows to notify that second cluster. You can see we started now over here. So this is as exciting as it gets. We've turned gold over here. So we've got this now where this second cluster has gone, hey, look, there's some data. I need to grab that data. What we do is we take that change of data, and we're bringing that over into that other cluster. So I'm going to switch over into that second cluster. So remember, the source cluster is outbound. Well, guess what? Inbound is the collection of that changed data. So if I click on this, we can see the fact that we've got a change that's occurring. So this second cluster has gone, hey, look, I've found your backup from the original cluster, and I'm going to do that pre-staging step. So remember my animation, we're watching the data, and then we're bringing that data over. It's actually a pull process. And what we've got now is that data is now available on this particular cluster over here. So we're now good. I've got my outbound is all good. So I've got no outbound processes done. And we are now ready to do a recovery of this particular set of virtual machines onto my second cluster. So that's the plan here. So this is my source cluster. If I go into here, these virtual machines, I'm now going to bring them over and run them over here. So there's no virtual machines that are running in this particular environment. And again, to do this, there's a variety of ways to do this. If you like to do follow the process of using this user interface, I can go through and click restore, and I can just do a normal restore. This is our restore screen, and we can go through and say, look, this is demo restore. I can restore this to this particular namespace. I can choose any excludes. For example, I might want to exclude some virtual machines out of this. I'll exclude that one, and I can go through that process and do a recovery using the user interface. But again, I promised excitement. So I'm going to go back into the world of Trilio, into the world of Ansible, and I'm going to do the recovery using Ansible instead. So I'm going to kick off this process where I'm going to do a recovery of these virtual machines based on this continuous restore. So in other words, I don't have to grab the data from my backup storage. And I'm going to do a quick recovery based on continuous restore. And I've kicked that process off using Ansible, of course. So what we can do now is this will change to in use. So one of these things, there we go. We've got in use. So again, this is really exciting. We've got gray now, and it says it's in use. So what we're saying there is we've got a snapshot, and we're making that snapshot as a basically primary storage available on this cluster. Now, if I quickly go and look into my storage and my persistent volume claims, you can see the fact that the storage is there instantly. So the remaining set of time isn't the fact that the storage there. So what we're doing there is we've changed this snapshot into the volume. So obviously it's going to be nice and quick. So no longer are we having to wait for 30 gig of data to be dragged over the network. In this case, it wasn't 30 gig. This is thin provision. It's only about 500 meg or a few gig in size. But the reality is we didn't have to wait for that time to take stuff over. It was instantly available on this particular cluster. And if I just go back into there, oh no, this is the world I need to go into. That was you realize that wasn't deliberate smoke and mirrors. This is where we're going to be finding our things. So let me just let's go through and wait. We're still waiting for these restores to occur. Let's give a quick refresh. Let's go through on the back over here. So we're still in the process of doing this recovery. We're going to DC2 to do the recovery over here. We can follow this restore quite quickly. So if I go to the Trilio backups and go to the overview, we've got a restore that is occurring on the back end over here. And if I can also follow this, just again, there's a lot of places to follow. I've got the Ansible over here. I've got my second cluster over here. So let's follow this as well on this side of the screen over here, right now. So we're still doing the validation, and now we're doing the recovery of the volumes and stuff. So I apologize. You had to do the validation, had to do the setup to make sure that we could do the recovery. And now we're in the process of doing that recovered of those volumes. So I've now switched to my second cluster, by the way, and here's my second cluster volumes. So most of the setup is actually just checking of things that are available. We've now got the instant recovery of our virtual disks, the PVCs. And if I go to my environment over here, we should see virtual machines start to pop up. I think it's around about 50 seconds. We should start to see virtual machines occur and pop up onto the hypervisor here. So to recap, whilst this is just in the final stages of telling the OpenShift Virt, here's some virtual machines to pop into this environment, I'm just going to do a little recap of what I've just done, because I went through a number of screens just here.
Kevin, so, just to raise this, so we are 5 minutes to finish the demo, and you might also want to have a look at the chat because I have seen some questions.
Okay, so we're just finishing off now, so that's brilliant. So I won't be able to do the OpenShift pipeline operator demonstration, but I'll go into chat. But you can see here we've now got our virtual machines that are in the process of booting up from one cluster to another. So just to recap, I took these virtual machines, I did a backup using Ansible, which invoked Trilio. I then did a recovery of those virtual machines onto this particular cluster. And as I say, just give it a moment for the hypervisor to churn into life. And we now have virtual machines that are now running in this environment over here. So that's just in the process of just finishing off. So whilst we've done that, I'm just gonna go back and I will answer some questions whilst we've got the remaining 5 or 4 minutes of time. So I'm gonna stop this share. So thank you for your time. Hopefully that demonstration was really, really useful. More than happy to take you through stuff at a later date. So I'm going to stop this share, and I'm going to look at the chat window to see if I can find some questions to answer. So very quickly, so there's only a few things. So the slides will be shared, of course. And a recording will be made available of this particular session to all the attendees. Going back up the chat, there is a question about whether we're compatible with other types of virtualization platforms, such as VMware. Our tooling is very specifically designed for Kubernetes and for OpenStack. So if you're migrating away from VMware onto OpenShift Virtualization, then we're good. If you're moving into OpenStack, we're good. But we don't support VMware as a hypervisor itself. We don't have tools that exist that work in the world of VMware. If you're talking about some alternative type of Kubernetes platform that runs on there, then yes, that's Trilio for Kubernetes. But the focus here is all about OpenShift Virtualization. And I think that's the last questions. If I don't see any more questions, if there are any more questions, by the way, if you want me to clarify anything, please contact me at the end. So I'm going to just reshare my slide deck. I'm going to just give some details where you can find us again, just as a recap. So let me just bring this back up again over here. If you have any questions, please visit Trilio.io. You can email me. I'm Kevin Jackson. My email address is kevin.jackson@Trilio.io. Search for me on LinkedIn as well. You can ask me questions there. If you go to Trilio.io, there is actually a chat bot. It's not completely dehumanized. You will get to a human. So if you do have any questions following this session, please go there, and you will go through to a human when you start chatting through that chat bot as well. So again, if you've got any questions, more than happy to answer them for you. But I think that's it. Again, any more questions? We now have 2 minutes left. So any more questions, please feel free. If not, I genuinely thank everybody for being on this call today. I hope it was very interesting for you. We covered a number of scenarios, just to recap. We covered what Trilio is. We're an operator into OpenShift. We covered the fact that we back up containers, virtualization, persistent volumes, namespaces, deployments, operators. I didn't show you the operator piece, but we back up them. We integrate into ACM. We integrate into Ansible. We integrate into the OpenShift Console. We have our own user interface, which allows you to do everything. The advanced way of managing things down to the granular level and granular restores. I showed you continuous restore, which allows you to do fast recovery. So in this case, the end-to-end demonstration of the continuous restore of backup to recovery takes about, in my testing, small environment, took around about 7 or 8 minutes to back up those couple of virtual machines and disks to do the recovery onto another cluster. So hopefully that fits within your SLAs, for example. So hopefully that was really useful, but please reach out for any more questions. Thank you.
Thanks so much, everyone. Thank you.